So just start your brief intro. First of all, give me your brief intro about yourself.
Yes, sir. Sir, my name is Sachin Singh, and I have done my schooling from Kendriya Vidyalaya in Triusganj in 2015. After that, I joined for Bachelor of Technology in Mechanical and Automation Engineering from Govind Ballabh Pant Government Engineering College that is affiliated to Guru Gobind Singh Indraprasth University, and I completed my B.Tech in 2019. And I have done my summer internship that was industrial training at PPCL, that stands for Pragati Power Corporation Limited, for 6 weeks. And I have done two projects. One was minor project and other was major project. The major project was about the collection of floating waste in the river by using the energy of flowing water only. And the minor project was comparison of two refrigerants, uh, uh, refrigerant 290 and refrigerant R12, to replace R12 uh, by R290. Yes, sir.
Hello. Okay. So can you just tell me why you compare the two refrigerants? What are the different properties you are just observing?
Yes, sir. We were observing for the thermophysical properties of the two refrigerants, and we were also then after we were comparing the COP that could be given by the refrigerants. We did the simulation of on engineering equation solver software, and we did the simulation. We did this project as the R12 refrigerant, which stands for dichloro-difluoromethane CCl2 F2, is having high level of ozone depletion potential and global warming potential. And it is currently being used in refrigerant. It is currently being used as a refrigerant in air conditioning, while the other one that we wanted to replace it with, the R290, which is propane C3H8. The propane had zero level of ozone depletion potential, and it had three global warming potential, which was much lesser than the CCl2 F2. And in the simulation, we found that although the COP was being decreased by a very little margin, like zero 0.1 or zero 0.2, but we were having a eco-friendly and environmental safe refrigerant.
What is the formula for R290?
Sir, R290 stands for propane, and the formula is C3H8.
So there is no Cl element here.
Sir, there is no Cl element, there is no F element in it.
Okay. So why this R290 is not generally used nowadays when
Sir,
it is having
actually,
less
yes,
ODP?
sir. Yes, sir. Sir, it has low ODP and GWP, and yet it wasn't being used in the refrigerant as a refrigerant earlier. The reason being that the R12 refrigerant was I mean, the properties of refrigerant include one of the major condition, that it should be inflammable. So R12, the refrigerant CCl2 F2, it was non inflammable. It wouldn't got catch fire, while on the other hand the propane is highly combustible. But after, because of that the hole in ozone layer, the committee, that UN stated that we need to switch our refrigerants from chlorine free refrigerants. So slowly after development, the companies have started using propane in some of the research level refrigeration systems. And
Can you just tell
yes, sir.
me ammonia has a ODP label or not?
It does not has ODP, and it has very little level of GWP.
So when we have already ammonia, it is having a very less
Yes,
ODP,
sir.
and
Yes, sir.
we are not using the ammonia. Why?
Sir, we do not use ammonia because in case there is any leakage in the ammonia, it is toxic to to the humans, highly toxic to the humans, sir. Ammonia, and this is
Okay.
why it is not commonly used.
So as you say that ki R290 you are using, it is also the
It
inflammable.
is flammable.
So
It is
flammable,
flammable,
sorry,
sir.
yeah, it is flammable. So it will
Yes,
also
sir. Sir, it is
there
also a
there
cause of concern. Hello. Yes,
uh,
sir.
there are so many refrigerant which is having the very less ODP, but these are the some properties on which we are not using.
Yes,
So
sir.
how can you justify that this is your useful?
Sir, actually, just being hydrocarbon doesn't satisfy for the needs of a refrigerant. There has to be some thermophysical properties as well, like like boiling point and the latent heat absorbed by the refrigerant, and the thermal conductivity should also be within the range of our application, practical application. So we compared R12 and R290 just because we earlier compared the thermophysical properties of both, and it was found that the R12 was having a boiling point of minus 40 degrees Celsius, and R290 was having a boiling point of minus 38. So they were having similar, almost similar boiling point. On the other hand, the latent heat was also very similar, and more importantly, the thermal conductivity of R290 was better than R12.
Okay, can you just tell me what do you mean by grand sensible heat factor, GSHF?
So grand sensible heat factor, it comprises of two heat factors. One is latent heat factor, that is heat absorbed through the moisture of the air, and sensible heat factor, that is the heat absorbed by temperature difference.
If I just want to design the AC, so how can you define the GSHF?
I want to design an AC. Sorry, sir, I cannot recall.
Can you draw this on the psychometric chart?
Yes, sir.
No, it's not correct. ग्रैंड सेंसिबल हीट फैक्टर बोल रहा हूँ मैं, सेंसिबल हीट फैक्टर नहीं बोल. ओके, सो प्लीज रीड इट. दिस टॉपिक है ना, ग्रैंड सेंसिबल हीट फैक्टर, और तुम्हारा जो प्रोजेक्ट है बेसिकली बेस्ड ऑन द आरएसी. So DRDO will definitely ask the question from the RAC level, or they are trying to go to the approach, practical approach. So practical approach generally हम AC और domestic refrigerator की बात करते हैं, है ना?
Yes, sir.
थोड़ा इसको टॉपिक को देखना, बाकी ओवरऑल यू आर गुड. कुछ प्रॉपर्टीज R290 की पढ़ के जाना. R290 का नॉमेनक्लेचर हम कैसे फाइंड आउट करेंगे ये भी थोड़ा देख के जाना. Surely they will ask you about that, है ना? Overall you are a good Sachin, है ना? Now the other faculty will take your snap, mock full mock.
Okay, sir.
Over to you, sir.
Okay, thank you, sir. Thank you. विशाल सर, आप भी हैं यहाँ पे? हेलो.
Yes, hello sir, I'm there.
ठीक है सर, मैं 5 मिनट के अंदर अंदर मैं लेता हूँ, फिर आप आएगा सर. ठीक है सर.
Sure sir.
Okay. Okay, Sachin. Let's start with the simple question from RAC itself.
Yes, sir.
तो साइक्रोमीटर चार्ट बनाओ और मेरे को बताओ भी एक्स एक्सिस वाई एक्सिस पे क्या होता है.
Yes, sir.
ठीक है, तुम एक्स एक्सिस वाई एक्सिस बताओ क्या होता है.
Sir, the x axis has temperature, increasing temperature towards this side, and it is humidity on y axis.
कौन सी ह्यूमिडिटी?
So it is absolute humidity.
एब्सोल्यूट ह्यूमिडिटी. एब्सोल्यूट ह्यूमिडिटी
एक सेकंड सर.
क्यों है?
नहीं,
नो सर, स्पेसिफिक ह्यूमिडिटी होती है. देख लो.
स्पेसिफिक ह्यूमिडिटी. यस सर, सॉरी सर.
अच्छा, पहले तो डिफाइन कर दो भी जो नीचे वाला टेम्परेचर है वो कौन सा टेम्परेचर है.
सर ये टेम्परेचर,
हाँ, कौन सा टेम्परेचर है? हम
सर इट इज इन डिग्री सेल्सियस.
डिग्री सेल्सियस, ठीक है. इसका नाम क्या है? टेम्परेचर भी 3-4 तरह के, वेट बल्ब टेम्परेचर, ड्राई बल्ब टेम्परेचर, ड्यू पॉइंट टेम्परेचर, इनमें से कौन सा है?
सर दिस इज ड्राई बल्ब टेम्परेचर.
ओके. और वेट बल्ब टेम्परेचर कहाँ होता है?
Sir, wet bulb temperature are inclined lines.
ओके, और ड्यू पॉइंट टेम्परेचर कहाँ होता है?
Sorry sir, I am not able to recall
ओके,
it.
कोई बात नहीं। अच्छा, वेट बल्ब टेम्परेचर मेरे को प्रैक्टिकली मेजर करना है, कैसे करूंगा?
Sir, we can cover the bulb of the thermometer with wet cloth or with wet cotton. It will
और
give
उससे
us
क्या
wet bulb
होता है?
temperature.
उससे क्या होगा?
Sir, it will cause the moisture content in the cotton. It will get evaporated
ओके।
into the air. So we will get a little bit lesser temperature in the thermometer if the air is being evaporated and the surrounding air is not saturated.
ओके
Then only evaporation will occur, sir.
ओके, तो अब ये काम करते हैं,
Yes, sir.
इसी साइक्रोमेट्रिक चार्ट में तुम अपने रूम का पॉइंट ड्रा करो कि तुम्हारे रूम की कंडीशन क्या है,
Yes, sir.
टेम्परेचर कितना है, ह्यूमिडिटी कितनी है।
So can I take any random value for the specific humidity?
नहीं, मेरे को बताओ कि कैसे निकालोगे, रैंडम वैल्यू कैसे ले लोगे? ग्राफ में कहाँ पे हो तुम इस टाइम, तुम्हें पता नहीं है क्या?
Sir, temperature ये है.
टेम्परेचर कितना लिख रहे हो तुम?
Sir, 26 degree Celsius.
ओके, तुम्हारे रूम में 26 डिग्री सेल्सियस टेम्परेचर है और ह्यूमिडिटी कितनी है?
So
हाउ
humidity.
डू यू डिफाइन स्पेसिफिक ह्यूमिडिटी?
So specific humidity is the ratio of mass of vapor of water in the air to the mass of dry air.
तो कितना होगा ये?
So it should be 0.01.
0. अच्छा, रिलेटिव ह्यूमिडिटी कितनी होगी तुम्हारे कमरे की इस टाइम?
Sir, near about 50 to 60%.
50 to 60%। कहाँ के रहने वाले हो?
Sir, Delhi.
दिल्ली में 60% है इस टाइम? गूगल है तुम्हारे पास?
क्या सर?
गूगल
Yes,
गूगल
sir.
सर्च मार के देखो क्या है रिलेटिव ह्यूमिडिटी दिल्ली टुडे।
Sir, it is 84%.
84% लिखा हुआ है। बारिश हो रही
Yes,
है
sir.
क्या वहाँ पे?
सर बारिश का मौसम चल रहा है.
हम्म।
कल परसों हुई थी बारिश.
हाँ, तो 84% चल रहा है, तुम 60 बता रहे हो।
सर एक्चुअली मैं
अच्छा, जब
दिल्ली.
बारिश हो रही है, तो सपोज करो दिल्ली में तुम बैठे हो और बारिश हो रही है, अब कितनी रिलेटिव ह्यूमिडिटी होगी?
सर रिलेटिव ह्यूमिडिटी.
रिलेटिव ह्यूमिडिटी कहाँ पे कितनी होगी?
Sir, it will be above 98 or to 99%.
सॉरी,
It will be
98?
it will be above 95 to 96%. If it is
हाँ,
raining, then it
ओके
can
ओके।
be up to 99% as well.
ठीक है ठीक है। और नॉर्मल ड्राई डे में, ड्राई हो दिन, बारिश हुई ना हो काफी दिनों से, तो क्या रिलेटिव ह्यूमिडिटी होती है?
So it can be about 20 to 40% between.
ठीक है ठीक है। अब एक छोटा सा लास्ट क्वेश्चन है मेरा,
Yes,
कि
sir.
पूरे दिन में रिलेटिव ह्यूमिडिटी कैसे चेंज होती है और टेम्परेचर कैसे चेंज होता है, इसको प्लॉट कर दो।
Okay, sir.
कोई भी ऐसा नॉर्मल डे ले सकते हो, रेनी सीजन नहीं होना चाहिए उसको, मतलब सिंपल डे लेना, ड्राई डे।
ठीक है. सर एक सेकंड टाइम लगेगा थोड़ा सा इसमें.
कोई बात नहीं, लास्ट क्वेश्चन है मेरे तरफ से।
सर टाइम के टाइम भी लिख दूंगा मैं इसमें. और relative humidity. Relative humidity decrease. तो ये ऐसे. सर ये सर मतलब एक एवरेज डे की बात करें तो
टाइम कहाँ पे है?
सर ये जो 25 डिग्री सेल्सियस है इसको मॉर्निंग का टाइम ले सकते हैं और 35 डिग्री सेल्सियस इवनिंग का, और फिर उसके बाद वापस सर टेम्परेचर ड्रॉप होने लगता है।
तो ये 24 आवर्स का नहीं बनाओगे तुम तो सिर्फ सुबह से लेकर शाम का बनाया, रात का कहाँ गया? और रिलेटिव ह्यूमिडिटी में काम करो, अलग से कर्व ड्रा करो। एक्स एक्सिस में टेम्परेचर रखो, वाई एक्सिस में नहीं, मतलब एक्स एक्सिस में सिर्फ टाइम रखो, वाई एक्सिस में दोनों टेम्परेचर और रिलेटिव ह्यूमिडिटी दोनों इकट्ठे प्लॉट करो।
ठीक सर।
टेम्परेचर इंक्रीज होने से रिलेटिव ह्यूमिडिटी को क्या असर होता है ये बताना है मेरे को तुमने बेसिक।
सर रिलेटिव ह्यूमिडिटी टेम्परेचर इंक्रीज होने से सेम स्पेसिफिक ह्यूमिडिटी रहने से जो रिलेटिव ह्यूमिडिटी है टेम्परेचर के साथ डिक्रीज होती है। अगर टेम्परेचर इंक्रीज हो रहा है तो रिलेटिव ह्यूमिडिटी डिक्रीज करती है।
क्यों?
क्योंकि सर बिकॉज द टेम्परेचर विल इंक्रीज द सो द एबिलिटी ऑफ ड्राई एयर टू होल्ड मॉइस्चर इन इट विल इंक्रीज।
ठीक है, एक लास्ट क्वेश्चन और ले रहा हूँ।
ठीक है।
घर में फ्रिज का जो गेट है अगर मैं खोल दूं,
यस सर।
क्या वो कमरे का टेम्परेचर डिक्रीज कर पाएगा?
नहीं सर, टेम्परेचर इंक्रीज करेगा रूम
क्यों?
का। सर टेम्परेचर इंक्रीज करेगा क्योंकि सर मैं एक्सप्लेन करता हूँ कि जो कूलिंग वी आर ऑब्टेनिंग फ्रॉम द इवेपोरेटर कॉइल, or that is we are getting on the one side of the refrigerator, but on the other side we have condenser coil which is eliminating the heat. And not only heat, the work that is being done into the compressor, that also transforms in that also generates a friction heat. Frictional heat due to friction.
That's all from my side, Sachin. मेरी तरफ से भी तुम पास हो, good knowledge of subject.
ठीक सर।
Over to you, sir.
Okay, sir. Thank you. Yes. Hello, Sachin.
Yes sir. Good evening, sir.
Good evening, Sachin. So you are preparing for DRDO.
Yes sir.
Great. Sachin, so you mentioned heat transfer, thermo, IC engine as your favorite subject. So let me start.
सर आपकी आवाज थोड़ी क्लियर नहीं आ रही, और सर अभी हीट ट्रांसफर अभी हुआ नहीं है।
So you have not covered heat transfer?
No sir. IC engine RSE. Sir, actually, I was away in Agra because my aunt is sick, and I have just come today here only.
When is your interview?
Sir, it is on 11th of May.
So you are comfortable in this subject or not?
Sir, heat transfer, I'm comfortable. I'm able to do it in like 1 or 2 days only.
Okay, so you are going to revise. This time you have not revised.
So, sorry, sir.
Right. This time you have not revised. Fine.
I haven't revised HMTS.
Okay. So let me ask you some question from IC engine then.
Sir, are you Vijender, sir?
No, I'm Vishal. Vishal sir.
Okay, sir. Okay, sir.
Okay. So Sachin, can you tell us something about jet engines? Jet engine. Thermodynamic cycle a jet engine work?
Sir, jet engine works on Brayton cycle, and it is a gas turbine. Okay, I will explain it more. So, sir, the jet engine has the compressor on the first stage, compressor, then it has combustion chamber, and then it has turbine, and the jet engine produces power by thrust power, and by Newton's third law, and the air, the hot flue gases that are being escaped from the nozzle of the jet engine give the thrust to the engine to move it forward.
Okay, you are aware about ramjet engines?
Ramjet engine, I have heard the name, but I do not have its working principle idea, sir.
You know about ramming? What do you understand by ramming?
Ramming?
Yes.
Ramming is like hitting something.
You know, in ramjet engine, we are not having any compressor.
Okay.
So we are getting the compressed air by some kind of ramming action. So now, can you recall something about that, Sachin? What are ramjet engines?
Yes, sir.
So that is a kind of actually propulsion system which we use in a missile.
Okay. Sir, maybe it is, if I'm allowed to guess, then ramjet engine is maybe it is that, sir. Actually, combustion takes place inside the engine, and it exhausts with a very high velocity out of the engine, and which creates low pressure inside it. Due to that low pressure, it sucks air back into it, fresh air inside it, and then combustion takes place again, and then again after combustion the exhaust gases escape with high velocity, and which gives the thrust.
Can you tell us the difference, major differences between the air standard cycles, okay, and the actual cycles?
Air standard cycle and actual cycles. Yes, so the first of all, the in air standard cycles we assume that Cp, that specific heat Cp, Cv, and their ratio as well, the gamma, we consider them as constant in air standard cycles, but in actual cycles the gamma of the air decreases with increase in temperature. So that is the first difference. Then sir, we assume our working fluid to be ideal gas in air standard cycles, whereas in our real engines, air can behave like ideal gas, but it isn't actually an ideal gas. Sorry, sir, I'm unable to remember any more about it.
You know what dissociation?
Dissociation, yes, sir.
So can you explain some brief about that phenomena, dissociation?
So dissociation means breaking of the
Yes, yes. There's a disintegration of
sorry,
burnt
sir.
out gases.
Sorry,
This is
hello.
disintegration of the burnt out gases, Sachin.
Yes, sir. Yes, sir.
Mhm.
During combustion, the uh, actually the components of air get
Burnt out gases,
disintegrated
yes. Mhm.
in the burnt out
Okay.
gases.
Just tell us what happens actually when dissociation takes place in IC engine. What actually
Yes, sir.
happens?
Sir,
How does a loss? How does a loss
how?
to the engine? How does a loss that actually occurs in loss of power? That results in actually loss of power. Okay. So how dissociation results in loss of power of an IC engine? Dissociation, I got some idea. You explained some brief about that. Like it is a disintegration of the exhaust gases, burnt out gases at a very high temperature. Okay.
Yes, sir.
Like the nitrogen or carbon dioxide or maybe some other gases, CO2,
Yes,
they
sir.
disintegrate. Okay. And again, they integrate at low temperature. So
Yes,
what
sir.
actually happens? What actually happens due to
Sir, yes, yes. At higher temperatures, like nitrogen dioxide or this sulfur, not
carbon
sulfur,
dioxide?
carbon dioxide
Mhm.
disintegrates into its different elements, like N2 turns into nitrogen and other nitrogen, and the this carbon dioxide disintegrates into carbon alone and oxygen differently, and then after the combustion they
Fine,
absorb.
fine. That is fine. Sachin, just tell us the effect of dissociation.
So they absorb the
Mhm.
so the pollution or the law.
That actually I already mentioned that results in loss of power. But how actually it results in loss of power, that you need to explain. Fine. Sachin, tell us something about turbocharging.
Turbocharging, yes, sir.
Yes.
Okay. So sir, turbocharging is so basically turbocharging is used to improve volumetric efficiency of an IC engine. So turbocharging is having a turbine and a compressor on its different sides. So the exhaust gases that are being emitted from the engine, they actually power the turbine of the turbocharger, which is connected to the compressor on the other end, which is used to compress or to provide more air into the combustion chamber by compressing the intake air. So it increases the volumetric efficiency, and it is more used in hilly area. So because the air density in the hilly area is less.
Okay, can you tell us something about strain hardening?
Strain hardening, sir. During the extension of a material, the first it is elastic deformation, then after it it goes into inelastic deformation, and during inelastic deformation, uh, the molecules inside the material readjust their shape accordingly,
Mhm.
and which causes increase in strength of the ultimate strength of the material. It is called strain hardening, sir.
So cold working, strain hardening, work hardening, these are same or there is some difference?
So hot working is different, cold working is different. Hot
No,
working,
work hardening, strain hardening, and cold working.
so strain hardening, cold working. So strain hardening occurs in cold working, and the work hardening, I don't remember about it, sir. Work hardening, I don't remember.
Okay, so what advantage we get when we carry out some kind of work hardening or strain hardening?
Yes, sir. By work hardening, the toughness of the material is improved, the hardness of the material is increased, and
Are you
the
sure it
strength.
results in increase in hardness?
Yes, sir. It increases hardness of the material,
Mhm.
and
What is hardness?
so hardness is the ability to resist scratch on the surface.
Mhm.
Yes, sir.
So how the hardness is increasing and how the strength is improving in strain hardening?
So in strength, because of the so in the strain hardening, uh, after the elastic deformation.
Mhm.
Sorry, sir. I haven't prepared material science as well right now.
So you have not revised even strength of material.
No, sir.
Fine. So other than thermal part, which part you covered? Fluid mechanics. Are you comfortable? Fluid mechanics.
Yes, sir.
Fine. Okay. So tell us something about I think somewhere you heard about cavitation. So explain that phenomena, cavitation.
Sir, cavitation. Sir, cavitation occurs when the fluid is moving with a high velocity, and the pressure around the surface which it is in contact with, the pressure decreases below the vapor pressure of the liquid. So a bubble is formed over there, and as when the bubble that bubble bursts, so it uh, uh, causes crater on the surface of the material. It is called cavitation, sir.
What about characteristic curves of pump, centrifugal pump? So what idea actually, what information we get through the characteristic curves of a pump, centrifugal pump? Sachin, what
Sorry,
are
sir.
the main differences between a centrifugal pump and a submersible pump?
Yes, sir. The against a centrifugal pump. Yes, sir. In the centrifugal pump is a the motion of the liquid is in radial direction, but in
Mhm.
submersible pump the motion takes place in axial direction, and it is in multiple staging. The submersible pump has multiple stages in it to increase the flow of water. But in this uh, centrifugal pump, there the motion is radial, and we have impeller and diffuser in it.
Hmm. Okay. Sachin, what do you understand by hydraulic gradient line and total energy line?
Don't remember, sir.
Okay, my last question to you, Sachin. Can you explain second law of thermodynamics? How it is different from first law of thermodynamics?
So second law of thermodynamics states that it is impossible to construct a device produce which can work uh, without increasing the entropy of without causing any change in entropy of system or the surrounding. Or in other words, it can also be stated as the entropy for a spontaneous work of an isolated system always increases.
What is entropy, Sachin?
So entropy is the randomness or disorderedness of the particles. Yes, sir.
Okay, so suppose you are sitting in a room At this case, for example, if you want to calculate the entropy change of your room, when
Entropy change.
when
Yes, sir.
actually in that time period only we conducted this interview. Okay, for example, we started interview at 6:30, and now the time is 6:07. Okay, maybe 7:05 or 7:10. So in that
Yes, sir.
40 minutes time period, how much entropy is generated in your room? How you will calculate that?
So we will assume the temperature change of the room to be.
Go with all suitable assumptions, Sachin. Take sufficient time. Okay, don't be in hurry. Frame a kind of problem out of that. So we are interested in calculating the entropy change of your room and as well as the entropy generation.
Entropy generation. Okay, so it is del Q by T plus S generation. So as I'm using this laptop and I'm using fan and I'm using this tube light, so they are all producing. Hello.
Yes, yes. Go ahead. Go
Uh,
ahead.
ye- yes, sir. So they all are generating some amount of heat because of the electric current flowing in
Okay,
them.
let us consider fan is of 50 watt, the tube light is of 10 watt, the laptop is of also maybe close to 40-50 watt.
Yes,
Okay,
sir.
it is good to take it only 20 watt. Okay, maybe 10-20 watt.
Okay.
So
Okay.
10 watt laptop, 10 watt light source, and 50 watt fan.
Yes,
Okay,
sir.
and you can assume some energy, some heat output, heat loss from your body also, because
Yes, sir.
human body also going to release some energy continuously.
Yes, sir.
So now approximate that, and then give me some idea how you're going to calculate the entropy change of your room and entropy generation. Quickly, Sachin.
Sir,
First, tell me,
entropy.
you will consider room as a kind of closed system, open system, and why?
Sir, I'll consider the room as a closed system because
Okay.
the heat is not being transferred from the walls because
So
temperature gradient isn't enough.
in closed system, no heat transfer takes place between system and surrounding.
Sorry, sir. Matter will not transfer from the room.
Mass transfer. Fine.
Ma
Great.
Mass transfer will not take place, but
Okay.
the heat transfer can take place, but the temperature gradient isn't enough between the room and the surrounding currently.
Now quickly
And
come to the entropy change, Sachin.
so there will be entropy generation due to the friction, and because of the heat being generated, it will be summation of heat divided by the temperature of room.
Now, how you will calculate the entropy change of your room?
So it will be heat generated by all the appliances divided by temperature plus S
Which temperature?
generation.
Which temperature? You are assuming there is the room temperature is something constant.
No, sir. It will be different between the source and the surrounding. It will be taken as different temperature. It will be delta Q by temperature uh, of the room minus a delta Q divided by temperature of the appliance.
Fine, Sachin. Okay, now I think I can provide you the feedback.
Yes, sir.
देखो सचिन थोड़ा सा आप कॉन्फिडेंट आपका कम लग रहा है ओके एंड आई फील इट इज ड्यू टू बिकॉज यू हैव नॉट रिवाइज्ड दी सब्जेक्ट लाइक
Yes,
हीट
sir.
ट्रांसफर फ्लूइड मैकेनिक्स एंड स्ट्रेंथ ऑफ मटेरियल
Yes, sir.
just by covering thermodynamics heat transfer and ice engine you will not be able to crack this interview so interviewer they are going to ask you questions from heat transfer also strength of material also fluid mechanics also so all
Okay,
these
sir.
subjects you need to cover although time is less you are having 5-6 days so it is
Yes,
good
sir.
to cover at least basic of these subjects. Okay, and even if interview is asking you some question, it is good to try. Give a try. So when
Sir,
I even
yes,
just mentioned heat transfer, so that time I observed you are not comfortable in that subject. So first,
yes, sir.
you need to revise some basic part, and you need to try to answer. And if you are even if you feel you are unable to answer any difficult question, then you can say, "Okay, sir, majorly I revised these subject for my interview." Fine.
Yes,
और
yes, sir.
ये अभी मैं आपको इस क्वेश्चन पे आता हूँ अभी देखो जब भी ऐसा क्वेश्चन पूछा जाए सचिन पहले तो आपको स्टेप बाय स्टेप चलना है यू नीड टू फॉलो
Yes, sir.
दैट अप्रोच पहले
Yes,
लो
sir.
कि सर वी आर इंटरेस्टेड इन कैलकुलेटिंग द एंट्रोपी चेंज ऑफ सिस्टम एंट्रोपी चेंज ऑफ द रूम सो आई एम कंसीडरिंग रूम एज अ माय सिस्टम बिकॉज दैट इज अ रीजन अंडर इन्वेस्टिगेशन so sir as we can observe in the room there is very less or negligible mass transfer between the system and surrounding so we can accurately assume it like a closed system. Okay.
Okay, sir.
And even if you want to go with some kind of adiabatic condition, you can assume कि sir मैं मान के चलता हूँ कि heat transfer भी बहुत negligible है room से. It is almost like a, because walls are a kind of very low conductive material, so we can assume it like with negligible heat transfer. ठीक है?
Yes, sir.
तो
Yes, sir.
फिर तो केस क्या हो जाएगा? हीट ट्रांसफर जीरो है तो एंट्रोपी चेंज सराउंडिंग का तो जीरो हो जाएगा. सिस्टम का क्या
Yes,
होगा? अब देखो
Yes,
रूम के अंदर
sir.
एयर नहीं है, देयर आर सो मेनी थिंग्स देयर,
Yes,
तो
sir.
आपको वहां पे इक्विवेलेंट लेना पड़ेगा. तो सर डिफरेंट आइटम्स व्हिच आर देयर, वी कैन टेक सम इक्विवेलेंट, वी कैन रिप्लेस देम विद सम इक्विवेलेंट मास ऑफ एयर.
Yes, sir.
ठीक है, तो उसका इक्विवेलेंट आपको निकालना पड़ेगा. लाइक ह्यूमन बॉडी है, बुक्स है, अलमीरा है, फर्नीचर है, देयर आर सो मेनी थिंग्स. उन सबका इक्विवेलेंट मास ऑफ एयर यू नीड टू टेक. ठीक है,
Yes,
और
sir.
उस इक्विवेलेंट मास ऑफ एयर को आप कैसे निकालोगे फिर एंट्रोपी चेंज? You can find out by using some entropy change formula of an ideal gas.
Yes, sir.
You can assume air as an ideal gas.
Yes,
ठीक है?
sir.
Is it clear, Sachin?
Yes, sir.
तो उसको Q by T मत करो, वो गलत हो जाएगा. Q by T तो हम सोर्स या सिंक के लिए करते हैं ना. तो
Yes, sir.
रूम
Yes,
कोई
sir.
आपका थर्मल एनर्जी रिजर्वायर
इसको तो
नहीं है.
ideal वो
थर्मल एनर्जी रिजर्वायर.
इक्वेशन लगनी थी तो उसमें CPCV वाली.
यस, तो आप उसमें
Yes, sir.
लगा सकते हो, क्या आप लगा सकते हो? CPLN
CPLN
आप
V1
लगा
by
लीजिए,
V2 by
या तो
V1
ये लगा
plus.
लीजिए
Yes, sir.
CVLN CVLN T2 by T1 प्लस RLN V2 by V1. तो वॉल्यूम तो
Yes, sir.
ऑलमोस्ट कांस्टेंट है, तो वो तो खत्म हो जाएगा.
Yes,
Okay,
sir.
so it will be CVLN T2 by T1. So T2 क्या है? Final temperature inside the room which you can measure, and
Yes, sir.
T1 will be the initial temperature, and that final
Yes, sir.
temperature also you can easily measure because you know how much work is entering, how much work you are doing on the system. So
Yes,
dq
sir.
equal to du plus dw.
Yes, sir.
ठीक है, अब आप अगर आपने रूम को इंसुलेटेड माना है तो dq will be 0.
0.
ठीक है,
Yes, sir.
and du plus dw, so whatever work you are doing that will result into the change in internal energy mcv
Yes,
dt.
sir.
बट
Yes,
वहां पे
sir.
m कौन सा लेना पड़ेगा? इक्विवेलेंट मास ऑफ एयर.
Equal. Yeah. हाँ, sir.
फाइन, तो उससे
Yes, sir.
आपका dt भी आ जाएगा, फाइनल टेम्परेचर आ जाएगा. सो कंक्लूजन क्या है सचिन? एक तो घबराना नहीं है, हड़बड़ाना नहीं है, वहां पे कंफर्टेबली सुनना है और
Yes,
स्टेप
sir.
बाय स्टेप आपको अप्रोच करना है.
ठीक सर.
स्टेप अगर मिस करोगे तो फिर आपको लगेगा कि यार ये तो बड़ा मुश्किल है. क्वेश्चन बेसिक होते हैं, बहुत बेसिक क्वेश्चन पूछते हैं वो, एंड दे आर गोइंग टू गिव यू द हिंट्स आल्सो. ठीक है, बट स्टेप्स आपको पकड़ के रखना है, और वट एवर यू नो यू नीड टू स्टार्ट फ्रॉम द बेसिक्स एंड यू नीड टू ट्राई टू एक्सप्लेन. ठीक है,
Yes, sir.
और कुछ भी छोड़ के मत जाओ. दीज आर वेरी इंपॉर्टेंट सब्जेक्ट और वो आपको कवर करना है. तो मेरे को ऐसा लग रहा है कि आप मेहनती हो, यू आर लुकिंग लाइक ए वेरी हार्ड वर्किंग स्टूडेंट, और आप मेहनत करोगे, एंड यू आर
Yes,
हैविंग
sir.
5-6 days also. So put your effort, utilize whatever time you are having, and go with full preparation and confidence in your final interview.
Yes, sir.